Okay, students, this is Mr. Langley, and I'm going to take you into chapter 1.4. Again, I want to encourage you as you're watching this, everything you see on the screen, copy it first, pause the recording, copy it, and then listen to my explanation so you have the notes for everything as we progress here. So I'm going to share this. Um, so chapter 1.4 is ratios and proportions. And so I've got a couple of definitions I want you to write down. A ratio here, something that is called a ratio, is a comparison of two numbers, and it's written in three different ways. Okay, so that's what it is. It's a comparison here of two different numbers. So for instance, the three ways you can do it are: one, you can do a ratio of 3 to 1. Okay, so I'm kind of spelling it out. That's one way you could do it. Say I'm talking about males to females. For every 3 males, there are one female. That's how that goes, because if you look at that sentence there, we have 3 to 1, and it says males to females. So the males goes with the first thing, okay? All right. A second way you can write a ratio, you'll see this in mathematics. This is the one you'll see the most, especially in algebra, is 3:1 here, just like I have here on the screen. This is called a colon here, and that's how you say it. If I said I had a ratio of 2 to 1, I would go 2:1, okay? And then the third way, sometimes you'll see it as a fraction here, 3 to 1, or better if I just write it out like this, 3 to 1. All three of those are ways of showing a ratio. Now, I'm an English teacher, so I'm just going to point out that in the word ratio here, that I'm circling on the screen here, it has two syllables, okay? Just like ratios are comparing two different numbers, okay? And in this case, my ratio that I'm talking about humans, males to females, but it's still the same kind of category, okay? Or quantity, humans, so males to females. However, when you're talking about a rate here at the bottom, a rate is the comparison of two different quantities, okay? So if I say that I am getting 30 miles per gallon in my Toyota, for instance, I might write it as 30/1, since miles and gallons are different, though. They're different quantities, okay? Because we've got miles, okay, as one quantity, and gallons as another total quantity. So they call that a rate, just so you know, okay? But the key concept here, right, mostly we're going to be dealing with in this chapter is ratios. So let me go to my next slide, and I want to show you something. Another concept that is a key concept is proportions. So please make sure that you are writing this down in your notes. When two ratios are equal, they form a proportion. And I'm going to move my little face out of the way here. So they form a proportion, and we call them proportional. That's what we just call it. That's a name for it. They're equal or proportional. So in my example here, if we have one man for every 2 women, okay, if that is my ratio, and then if we say, but we also have a class that has 5 men, that's the same as 5 men for every 10 women. Those are proportional. Why? Because if you look at it, if you reduce 5/10 down as a fraction, 5 goes into itself once, and 5 goes into 10 twice, so it reduces down. So these are proportional, okay? And, or here's another one. If I have 2 wins for every 5 losses in my Seattle Mariners baseball season, that sounds about right. Then if I said, well, is that the same as 4 wins for every 10 losses? Well, if I reduce down 4/10, it reduces down to 2/5, okay? Now, however, I do want to show you, how do you determine if something is proportional? Okay, and I'm going to touch on this again in a moment, but you can find out if something is proportional. What if they gave you these? If I circle this on the bottom, what if they gave you these two, and they ask you, are these two ratios, are they proportional? My pen's going crazy on me. Are they proportional? Okay, well, I'll tell you a little secret that you could do here. You could just multiply them, okay, crossways. So if I multiply cross, kind of cross multiply here, and take the denominators, okay, my denominator of 1 and multiply it with the numerator of the other like this. So cross multiply. 5 times 4 equals 20, right? And 2, if I multiply crossways like this, 2 times 10 in my ratio equals 20 also. If you cross multiply and you get the exact same answer, that means that they are proportional. Those two ratios are proportional, and that's the way that you check to see it. Okay? Going to go to another concept. Please be sure and have these in your notes. This is something called scaling. Okay, scaling is where you multiply or you divide the quantities by the same number. So if they say, for instance, what is 20 cents per minute? Okay, 20 cents per minute. Is that the same? What is that in every, is every dollar, how many minutes is that? Okay. Well, I know that 20 cents, if I multiply 20 cents by 5, I get 100 cents. Okay. And that's a dollar. This is a dollar right here. So since I multiplied that top by 5, if I multiply the bottom by 5, every 5 minutes I'm making $1, 100 cents. So that's one way of verifying, well, how much is 20 cents a minute? How much is that an hour? I can scale it up to a dollar and figure out how much that is every 5 minutes. So I'm multiplying by the same thing, the numerator and the denominator, and I am now I'm scaling it. And also, by the way, coincidentally, if I had, say, for instance, this ratio, 20 over 5, and I wanted to scale it down and see, what that is. If I divided both sides by 5, okay, you can see that that would very quickly get me a 20 goes into 5 4 times, and 5 goes in once. So that's the same ratio. I've just scaled it down. Okay, so that's called scaling, where you multiply or divide the two quantities of your proportion by the same number. All right. How do you determine if two ratios are proportional? We've already done that. We talked about that in the example previously where you would just cross multiply, okay? And in this case, are they proportional? We got 40, and 10 times 4 is 40. So cross multiplying, yes, they're proportional, okay? Now, what would you put as an answer if one of them, let's say, for instance, I got one was 41 and the other one was 40. Would you say they're proportional because they're close? The answer is no. You would just say not proportional or no. They have to be exact. Let me give you a second example down here. I've got example B, and there's a diet that calls for 25 grams of fiber for every 2,000 calories, okay? And a person proposed, well, I've got a diet that's 30 grams of fiber for every 2,500 calories. And if they ask you, are these proportional? Are these two diets, are they proportional? Are they okay? What would you do? Well, to find out if they're the same diet or same proportional, I would multiply the 2,000 times the 30 and get a big number, okay? That's about 60,000. That's about what I get. And if I multiply 25 times 2,500, would that give you the same answer? I'll let you do that on your own. But if you got the same exact answer, then you would say, yes, they are proportional, that those diets are equal to each other, okay? All right, now I'm going to give you a little bit of homework help because I'm just going to put it right into my lesson here. And let me start with number 2. I want you to do, actually in this lesson, I want you to do 2. Even though ordinarily I'm going to have you only do the odds, 1, 3, 5, 7, and 9. In this lesson, I also want you to do 2 because I want you to practice scaling. So I'm just going to kind of show you how I would do this one. And this will also appear, by the way, should appear on one of your first exams, okay? So 2/10 equals what over 5? I got a box here, okay? Well, here's how I want you to think about this. Start with what you do know. How did this 10 right down here, how did it become a 5? Okay, how did I get it down to 5? I must have divided it by 2. Okay, 2 goes into 10 5 times. So remember, if you multiply, when you're scaling, if you multiply or divide by the same number to the top and the bottom number, that's scaling. Well, if I divided 10 by 2 and I get 5, If I divide 2 by 2, okay, do the exact same thing to the top number, I get 1. So that's what you would put in this box, okay? Now the next one, 1 over 5 equals what over 20? Well, how did my 5 get to 20? I must have multiplied it by 4. So since I do that to the bottom, I'm going to do it to the top here. And so 1 times 4 is 4. So there's my answer there, okay? And the next one, how did my 20 become 100? I must have multiplied it by 5. So got to do the same thing up here, and that'll give you 20, okay? So that's scaling, and you'll see one like that on your first exam. All right, number 1 on your homework says, Maddie lost 18 pounds in 8 weeks. Find her rate of pounds lost per week, okay? And so 18 pounds in 8 weeks. So I just kind of wrote the ratio right here that I'm circling on the screen here. It wants to know, and I kind of want to encourage you to do this as well. How many pounds lost per week is what it's actually asking for, pounds per week, okay? Well, how am I going to scale weeks down to 1 week? If I divide the bottom number by 8, okay, I have 8 weeks divided by 8, scales it down to equals 1, okay? So I divided the bottom number by 8. So if I divide the top number by 8, okay, I'm going to get an answer, and it's going to be approximately, it'll equal like 2.25, or if you had 2 1/4, that would be okay as well, okay? So this is how many pounds were lost. Okay, I'm going to draw a little arrow here to it. We're talking about pounds here. That's how many pounds were lost per week. So that's how you would figure that one out. Okay. Question number 3 asks you to write, it says, suppose the sales tax in your town is 8%. Write at least 3 interpretations of this ratio, okay? And I want you to think back to how I basically showed you this right here on the screen, right? The 3 different ways that you could show a ratio here. That's basically what it's asking you to do, is to kind of write that out 3 different ways. So 8% is 8 over 100. I'll let you kind of figure out the rest of those. And let's see here. Here's number 5, just a little bit of help with that one. If the ratio of boys to girls in a student's class is 5 to 7, what fraction of the class is boys? And I really encourage you to do what I just did here. You'll notice that I underline or I circled the fraction of the class. They want to know what fraction of the class is boys, okay? Now, some people would get this wrong because they would just go, oh, it's 5 over 7. That's my answer. But, but that's not what the question is asking me, okay? So if it says the ratio of boys to girls, the first number I got was boys, okay? So boys to girls. So it's boys, and then for every 5 boys, there are 7 girls. But the question's not asking that. It's asking of the class, okay, of the whole class. So how am I going to figure out kind of the ratio of the class, boys to the ratio of the class? Here's what I want to do. If I add 5 and 7 together, I'm going to get 12. Okay, that's both ratios added together. That's like, that now represents everybody in the class. And how many of those 12 are going to be boys? 5 out of the 12. So that's how I would tackle that particular problem, is I would add the 2 ratios together and get a total, and that's now the whole class, how many kids are in the class. And then I can take the 5 left and put that over 12. And by the way, that fraction does not reduce, okay? So that's a little bit of help with your homework. I hope you found this video helpful, and be sure and shoot me questions if you have any, and I'll be glad to help.